All right, guys, the last conic section we're going to do is called a hyperbola. Graph and write equations of hyperbolas, not a hyperbola, but it's called a hyperbola. And it's the last conic section we're doing, last part of a cone. All right, a lot of stuff on this slide. A hyperbola is a set of all points such that the difference of the distances between P and two fixed points called the foci, again, is constant. So here's what happens with the hyperbola. First of all, if you look at a hyperbola, this curve right here and this curve right here, those are called the hyperbola. Think about if you flip those backwards. Like if you flip this one this way, you flip that one that way, you would have an ellipse. So it's really an ellipse backwards. So basically what happens is if you find the distance from that point to there and also from that point to there, you subtract them, it's always going to be the same no matter which point you pick. So that's the difference, and that's not a big deal if you don't get that completely, but you need to get the terms here. The line that connects, or let me just teach you here. The vertices are these points right here. Let me come down here. The vertices are the points think about it this way almost. A hyperbola is like two parabolas, and so it has two vertices. Okay, one vertex at the bottom or top of each parabola. The transverse axis is a fancy word. That's called the major axis. The major axis is the one where the vertices are. Okay, so like on this one I'm drawing on, you probably can't tell. This one right here, the x-axis would be the transverse axis. On this one, the y-axis would be the transverse axis because that's the axis that it touches. All right, now, if you notice on this picture, there's like a rectangle drawn and two lines going through the corners of the rectangle. Those lines are called asymptotes, which you know, you've seen those before. And the box tells you kind of how wide or skinny to draw your the asymptotes and how wide or skinny to draw your hyperbola. All right, now the equation is just the opposite of what we did yesterday. If you look at this down here, if it's a horizontal, if it's the x-axis is the major or transverse axis, the x squared comes first. Now, it's not about the a squared today. It is about the a squared. But the a squared today comes first every time. It's the positive one. It's got to be the positive one. So if x squared comes first, your hyperbola opens left or right like the x-axis. If your y squared comes first, your hyperbola opens up and down like the y-axis. Okay, so those are the big words. Foci, vertex, no co-vertices today. And also transverse axis is the major one. The foci today are going to be found by this equation. It's going to be c squared equals a squared plus b squared. Okay, yesterday we had a squared minus b squared. Today we're going to a squared minus b squared to find the foci. And that's on here. I jumped the gun a little bit. Okay, here we go. If it's a horizontal transverse axis, meaning major, the x squared comes first. A squared is first. Asymptotes, that's how you find your asymptotes, and I'll show you that in just a second. And your vertices are your A, just like we did yesterday with ellipses. If it's a vertical transverse axis, the y squared comes first. Asymptotes are flipped, and the A comes second because it's on the y-axis instead of the x-axis. Now, that's a lot of info, and I think it'll make more sense when you see I have two examples coming up, and really watch the two examples really well. All right, graph 25x squared minus 4x squared equals 100. Identify the vertices, foci, and asymptotes. Okay, so here we go. First of all, 25y squared minus 4x squared equals 100. Just like yesterday, I need that side to be 1. So I'm going to divide every single term up there by 100 because that's what I want my equation to look like, if you notice from the last slides. 25 goes into 100 4 times. 4 goes into 125 times. So there's my equation. Now, one thing about that equation, my y squared comes first. Okay, which means it's the transverse axis. So I'm going to go up 2 and down 2 on my y. That's my vertices, by the way, because it comes first. So my vertices are plus or minus, sorry about that. Need a 0 first. There we go. 0 plus or minus 2. Those are those 2 points. But also asking for the foci. To find the foci, I'm going to do c squared is a squared plus b squared, which is 4 plus 25, which is 29. Take the square root is plus or minus square root of 29. Now the foci are always on the major, so when I write my foci, I'm going to use a 0 again, plus or minus square root of 29. That's what the foci are. Now square root of 29 is like 5 point something, so that's about right there. That's a focus. Negative 5 point something is about right there. There's a focus. And the last thing it says is the asymptotes. Now the asymptotes, watch what I do for the asymptotes. Look under my x. My x has a 25 under, so I'm going to go right 5 and left 5 like I did yesterday. Now instead of connecting this like an ellipse, I'm going to draw that rectangle that you saw. Okay, I want to change colors here. That rectangle is going to do it like this. It's going to do it like this, this, this. Okay, there's that rectangle. Now the reason you draw the rectangle is so that you can draw the asymptotes. Okay, there's a vertex, there's a vertex. The asymptotes are going to connect the corners. They're going to go through the 0, 0, connect the corners of the rectangle like that. There's one asymptote. Here's another asymptote. And now your hyperbola is actually going to look like this. Okay, it's going to look like that. It's going to look like that. Now, the last thing here, though, says identify the asymptotes. So the asymptotes are going to be always y equals plus or minus, and just find the slope of the asymptotes. All right, look right here. It goes through 0, 0. We're rising 2, running 5 to get there. Rising 2, running 5, rising negative 2, running 5. It's plus or minus 2/5 because it's rise over run x, 2/5 x. So my answers is the graph, colorful graph, my equation, my vertex, my foci, and my asymptotes. Okay, now the next slide we're going to do all this backwards. Okay, this one says write an equation of the hyperbola with these foci and the vertices at -3 and +3. Now one thing I know already, I'm going to go ahead and put my x squared over something, minus y squared over something, it equals 1. Now because the vertices are the x coordinates, that means the x is a transverse, which is why I put the x first, by the way. I didn't just do that randomly. I know when I talked through that, I probably just said, oh, x squared minus y squared. But the reason I put the x squared first is because that's where the vertices are. And if I square to 3, you get 9. Remember, it's a squared down there. That's always a squared. Now, what I need to go underneath my y squared is a b squared. Okay, so I'm going to have, remember this, c squared is a squared plus b squared today. There's my c right there. C is how far the foci are. So c is 4, plus or minus 4. If I square that, that's 16. A squared is sitting right there at 9, and b squared is what I need. So it's asking you, what would you add to 9 to get to 16? Hopefully you know it's 7. That's what b squared is. And this is the weird thing again today. It's happened yesterday. I don't care what b is. I need b squared in my equation. B squared is 7. There it is. There's your equation of the hyperbola. All right. Hope that makes some sense to you. It's the last shape we're doing, and I'll see you tomorrow. We'll obviously clear it up for you tomorrow. So see you then.